So what's up guys, welcome to this video where we will be going over October 2021 Edexcel mechanics. Let's go. So question 1, we have a particle P. It moves with constant acceleration 2i minus 3j meters per second, and at time t is equal to 0, P is moving with velocity 4i. We need to find the velocity of P at time is equal to 2 seconds. Okay, so for this question, because it has constant acceleration, we can use SUVAT. So if I use SUVAT for this one, well then, what is our S value? Well, we don't know what S value is, okay, so we can just leave that as S. Now our U value, our initial velocity, well, we're told that when t is equal to 0, it's moving with 4i, so therefore U would be 4i. V, that is what we want to work out, so that can stay as V. A, they tell us the acceleration, which is 2i minus 3j, and we want to find the velocity when t is equal to 2 seconds, so t is 2. So we have V, A, and T, and we want to work out U. So we can use the SUVAT equation of V is equal to U plus AT. And if we do that, therefore it would be a V is equal to a U, which is a 4i plus a 2i minus 3j times by 2. And then if you work this out, you get a 4i, 2i times 2 is a 4i, 3 minus 3j times 2 is a minus 6j. Then if we just, that's a j. And then if we just simplify this down, we get V as being 8i minus 6j. So for part B, we have that at time t is equal to 0, the position vector of P relative to a fixed origin O is I plus j meters. We need to find the position vector of P relative to O at time t is equal to 3 seconds. So normally when we have the fixed origin O, usually that is just at like 0i plus 0j, it's just 0, right? So never really have to really consider it. But in this case, the origin O is at I plus j. So it doesn't matter where our position vector is, it's going to be we have to think of that position vector from I plus j, okay? So therefore, what we have to do is when we think about a SUVAT equation, in this case, it wouldn't just be S, okay? Because what you can think about is usually when we look at it from a fixed origin, usually it's just like OO, right? So we can think of it as being like 0i minus 0j. It's just going to still stay as S. But this one, because we know that we are I plus j meters away, therefore, that means that whatever our position vector ends up, we have to minus the I plus j, okay? Because it's going to be a distance from I plus j. Therefore, in this question, our S would be S minus I plus j, okay? And then for our U would stay the same as before, okay? Our U would still be a 4i. Or A, that would be still be a 2i minus 3j, and we will use, we've got that t is equal to 3 seconds, so therefore a t is equal to 3. And then now using these values, we can use the SUVAT equation of S is equal to a ut plus a half at squared. And if we do that, we get an S minus I minus j, that is equal to a 4i times a 3, that is a 12i. Then we have a half, and then we have a 2i minus a 3j, times a 3 squared, that would be a 9. And if we work all this out, we get an S minus I minus j equal to a 12i. We will just do 9 times a half first, so we get a 9 over 2, and then in brackets we still have the 2i minus the 3j, and then let's expand this out, so we still have the S minus I minus j equal to a 12i. A 9 over 2 times a 2, that is just going to be a 9i, and then we have 9 over 2 times a minus 3 is a minus 27 over 2, as decimal that would be a minus 13.5j. And now if we just add on our our I and j values from the left side, we get S is equal to, well, we bring that minus I over, so we get a 1 plus a 12i plus a 9i, so that will give me a 22i, and then we get a We get a plus 1 over on this side too. So we plus that, so that will give me a minus 12.5j. Okay, and that would be an answer. 22i minus 12.5j. So for question 2, we have this pulley question, okay? So we have this small stone A as mass of 3m. We have a small stone B of mass m attached to the other end of the string. Initially, A is held at rest on a fixed plane. So let's just input what we have right now. So on the next page, I have a diagram here. This is input what we just learned there. So we know that stone A has a mass of 3m. So if I just draw the weight, so that would be a downwards weight of 3 mg newtons, okay? We're told that stone B, that has a mass of m, so we know that there's going to be another downwards weight of just m, do small m, of just another mg newtons, okay? What are we also told? So held at rest on a fixed rough plane. So we know that there's going to be friction on that slope, okay? It says that A is on a fixed rough plane, so there's going to be friction there. So we know that, okay? What do we also know? We know the plane is inclined to the horizontal at angle alpha, so we know that here that's angle alpha. We have the string passed over a pulley P, which we can see. Parallel line of greatest slope. Stone B hangs freely. We know the coefficient of the friction is 1 over 6, so we know that mu, okay, mu is 1 over 6. And we know that the stone is released from rest and begins to move down the plane. Okay, so therefore, if it moves, that means that let's draw an arrow for acceleration. Acceleration is in the downwards direction. Also, we know that it's on a rough plane. We know that friction always works in the opposite direction. So we're gonna have a frictional force going this way. Now I can't redraw it on the graph. But we know that we're going to have a friction going in the opposite direction on the slope. And we also could be dealing with pulleys, okay? It says, what does it say here? Okay, so we know the string is modeled as light and inextensible, okay? And because we know that as well, that also tells us that we also will have the tension. There'll be tension here and here, which will be the same, okay? And we'll call that T newtons, okay? So again, what do we have here? Well, we have that this in the pulley system, okay, the stone A is moving down the plane, and if stone A is also moving down the plane, that also means that stone B that will move up the plane. So this will also be acceleration meters per second. Okay, so we really have kind of everything we need to know now. One last thing we can also say is, let's say there's a right angle here. We know that this would be the sine alpha here. Okay. Now everything we need to know. Now, what is the first question? The first question is, so we need to, using the model for the motion of the system before B reaches a pulley, write down an equation for the motion of A. Okay, an equation for the motion of A. So if we write down an equation for the motion of A, well, we know that F is equal to ma. Then we need to do resolve forces. So in this case, if we do R in the downwards direction, going down the slope, then what would that be? Well, there is a downwards force for A, that would be the weight, so that would be the 3 mg sine alpha, okay? Sine alpha, and then that is minus, maybe hard to see here, but we also have this frictional force here, okay? And then we also have the T, they're both going in the exact same direction. So therefore we have the friction and the tension going against it, okay, and that is equal to mass. Well, the mass is 3m A, okay, because A is acceleration. Okay, and that is it. That's all you need to do for part A, okay? Write down an equation of motion. We've given an equation for the motion of A, for stone A. So that's it for that question. So for part B, we need to show that the acceleration of A is 1 over 10g. Okay, so to do that question, we're going to need to work out our F's and our T's. Okay, so we know that the equation for friction is mu r. Now in our diagram, we didn't need to actually have the normal reaction down to do part A. But in this question, we need the normal reaction. So where is the normal reaction in relation to A? Well, because the plane has friction, okay, therefore the slope has friction, then we know that it's going to be perpendicular to the slope. So therefore, we're going to have the normal reaction is going to be in this direction here, okay? So we can call that R newtons, okay? And now what we need to do is, if we can work out our F and our T values, we can actually get an equation for A. So first things first, let's rewrite that equation we have up here. But let's actually get some values going. So for example, what else can we do? Well, we know that in the question, we know that tan alpha is equal to 3/4. So what does that mean? Well, that means that if we were to draw a little triangle here, right angle triangle, therefore we know that this would be a 3, this would be a 4, and this would be a 5. Therefore, we'd have a sine alpha as 3/5 and a cosine alpha as 4/5, okay? And now let's try and work out some of these values. Well, because if we look at our diagram, okay, we have that R newtons. Can we kind of work out an expression for that R newtons? Well, we actually can, okay? Because for the R newtons, if you look at the diagram, if we think about it in the same direction as that R newtons, like there's only one other force which is going against it, and that would be the 3mg. That 3mg would be the only force, but it'll be going in the opposite direction. So if I just draw a little line here, this angle here, okay, that's an angle alpha. So that'll be in the opposite direction. So actually we can work out the R straight away. So if we do that, we would get an R, if we resolve forces in this direction here, that would simply just be R, okay, because that's just the R here, this direction. And that would go against this direction here, which would be the 3mg cosine alpha. So therefore, that's just a 3mg cosine alpha. Okay, so now if we work this out, we get R is equal to a 3mg times a 4/5, which therefore means that R is equal to a 12mg/5. So we know that R is equal to a 12mg/5. Now, using that, we can actually work out the frictional force. Because we know that F is equal to a mu R, we know what mu is, they tell us that in the question. So we know that F is equal to a mu, which is 1/6, times by the 12mg/5. And if we work this out, what do we get? We get a 12mg/30, which cancels down to a, you can divide both by 3, so that will be a 4 over, oh wait, no, what am I doing? What am I doing? Not just 3, can divide by 6, so that will be a 2/5mg. So know that F, our frictional force, is going to be a 2/5mg. Okay, so that is our F done. So now if we look at this equation we worked out in part A, all I'm doing is I'm just going to work out this F value, then this T value, and we know what sine alpha is. And once we know all those values, we can just plug in all those values to that equation and get an expression for A. So now I've worked out this F value. We know F is 2/5mg. Now I'm going to work out this T value. So for this T value, well, it's not actually too difficult to work out this T value now. But what I'm going to do is I'm going to use stone B now, which we haven't really touched yet. So I'm going to use this T value because with this B value here, we can get an expression for T. And whatever that expression for T is, we can just put that into our T here. So let's work out, let's look at the tension at stone B, okay? Because the tension at stone B, the tension over here is going to be the same tension as this, okay? So let's work out the tension at stone B. So if we do that down here, if I just write like B, for example, well, actually, let me just copy my diagram down as well. So for stone B, if we resolve in the upwards direction, because that is the motion, then that would be a T okay, minus an mg, okay, could we just have upwards versus downwards, and that would be equal to mass, which is just m, times acceleration, which is just a. And if we just rearrange this, we get a t is equal to an mg plus ma. And obviously that tension is the same as tension in A. So now we have an expression for T. We can just put that into our equation up here, okay? We can put it into this equation up here, okay? And then we can now just get an expression for T. So now that we've worked everything out, we can use that same equation from part A. So we have the 3mg sine alpha minus f minus t is equal to 3ma. We know that F, our friction, is 2/5 mg. We know sine alpha is 2/5, and we know T is equal to mg plus ma. Now we can just pull those values in, and we should get our answer. So if we do that here, we get a 3mg times by a 3/5 minus F, which is a 2/5 mg, and then minus T, which would be a minus G minus ma. And that would equal a 3ma. Okay, so 3 times a 3/5, that is a 9/5 mg. Then we have the minus 2/5 minus the mg. So that'll be a minus 2/5 minus a 5/5. So that will give me a minus 7/5 mg. And then if we bring the ma to the side, we get a 4ma. And 9/5 mg minus a 7/5 mg, that would give me a 2/5 mg. That's equal to 4ma. So now if we just, we can work out a now. So it'll be a is equal to, alright, like this, a 2mg/5. That is going to be divided by a 4m. Okay, and that is the same as saying A is equal to a 2mg/5 times by a 1/4m, which therefore would be a 2mg over a 20m. Our m's cancel. That 2 goes down to a 1. This goes down to a 10. Therefore, we are just left with 1/10 g. So for part C, we need to sketch a velocity time graph for the motion of B from the instant when A is released from rest to the instant just before B reaches the pulley. So for this type of question, it's velocity time graph, so that means that the gradient is going to be our acceleration. Now, what do we know about this question? Well, this question, we know what the acceleration will be. We know it's going to be a 1/10 j, okay? But more importantly, we know that it's going to have a constant acceleration of 1/10 j. So it's going to have constant acceleration. Well, therefore, that's just going to be like a linear equation or like a linear line. It's going to be a straight line, okay? And we know that it starts from rest. So effectively, if we draw a velocity time graph, okay, we know that this is our velocity, this is our t. It's just going to be like a straight line like this, okay? And this straight line, that represents our acceleration, which, is going to be constant. This will be obviously before it hits the pulley, so it will just have a constant line like this. And then you need to justify your answer. So you can literally just say something like a straight line because it has constant acceleration. So and maybe just write something extra like gradient is, I don't know, the acceleration, just to make sure you're clear. The gradient is the acceleration. Have I even spelled that right? Probably not. Let's do like this, acceleration. Does that look right? Yeah, that looks right. Acceleration. And for part B, okay, we're told that in reality the string is not light. So how does this affect the working in part B? Well, very simple. When the string is light, what that tells us is that the tensions of the two equations are going to be the same. Because they're both light, right, we can kind of say that the tensions are going to be roughly the same, okay? So we always equate our two tensions to be the exact same. However, if the string is not light, it means that the tensions of both stone A and stone B, they're going to be different, okay? Because the different sides of the string would be supporting more weight, they could be accelerating differently, okay? So therefore, all you need to write is, if I do it down here, write something like if string is not light, then tensions the tensions of the equations would be different. Would be different because different sides of the string would be supporting. You don't need to put in this much detail as I'm doing, but I'm just doing as much as I can. Supporting more weight or accelerating differently. Okay, so you can write something like this. That will be fine. So for question 3, we have this beam AB of mass m and length 2a. So again, they mentioned that the length is 2a. So already, I pretty much know that we're going to have to use moments at some point. We know that the beam rests in equilibrium with A on rough horizontal ground, so there's going to be friction at A, and with B on a smooth vertical wall, so there's no friction at B. It's inclined to horizontal at angle alpha. The coefficient of friction is mu. It's a model as uniform rod, so know that the mass is going to be at the center of the beam. And then using this model, we need to show that mu is greater than or equal to half cot theta. Okay, so how can we work all of this out? So let's start with putting our mass in first. So we know it's uniform. So my diagram here, we know that it's going to be in the center. So let's say this is the center here. We know that this is going to be g newtons. Okay. What else do we know? We know the length as well. So we know that if the whole beam is 2a, we know that the length from A to the weight is just going to be A. We know that this will also be A as well. We have the angle theta. So know that the angle to the horizontal is theta. Okay. What else do we know? We know that we know we have mu as well. So for now, we know that we know the equation for F. So in this case, obviously there's loads of slightly different equations we can use for working out the friction. But in this case, we could have been given much values and also a trick because they have that it's greater than or equal to. We will write that F is less than mu R. Okay. And also knowing that, remember that we have friction at A, okay? So this is the thing now. Where would that friction go? And what other forces do we have applied here? Well, first and first, let's go to B first, because B will help us know the direction of the friction. So B, we know that B is at a smooth vertical, okay? But we know that at B, there's going to be some reaction happening to the wall. There's going to be a normal reaction happening to the wall. So what that would be is it's always going to be perpendicular to the wall. So there's going to be a reaction here. Let's call this RB newtons. Okay, that is the normal reaction at B. Okay, that is just horizontal to the left on B. Now we know that there's going to be a normal reaction at A as well because that's going to be to the ground. That'll be perpendicular to the ground. So that's going to be at RA newtons. Therefore, if we have friction, well, if it's at equilibrium, we must have a force. We must have like everything has to be balanced, right? So at the moment we have a horizontal left force, but we need something to balance that reaction at B out. So therefore, it has to be F. F has to be going to the right because it has to balance that RB force because we're in equilibrium, right? It can't go to the left, it has to go to the right. Therefore, we know that friction goes to the right. So now we've done all that, and we know that F is less than or equal to mu R, okay? Therefore, let's go and try and work this out now. Now, how can we work this out? Well, we have 3 unknowns right now. So if we try and resolve by forces, we're not going to get very far. Therefore, and this is also the fact that they say in the question that we have length 2a. That means that they want us to most likely use moments. So let's use moments. And where should we take moments? Well, the best place to take moments would be at A. So that is where we are going to take moments, okay? So let's add some other stuff as well. So also, if we have, this will have to be a sine theta here. And we also know that we may not need it, but I'm going to draw it in now. So, for your diagrams, always just do as much information as you can. It means you have less things to do later, okay? So that's going to be a theta there. Now, we also know that looking at this angle here, it's going to have an alternate angle right here as well. We may need it, we may not need it, but I'm going to draw it there as well. We can also think of this as being sine theta, if that helps. That's why that would be a theta there. We also know that, therefore, if we have another line, let's say going in this direction here, okay, we know that this would be a sine alpha, okay? So we've worked out pretty much all our alpha and sine alpha values we need to know. Okay, let's take moment to A. If we take moment to A, we get to eliminate two unknowns. We eliminate the RA newtons and the F newtons. So if we take moment to A, we'll just have the B. So if we take moment to A, therefore, what do we have? Well, we have the RB. Now the RB, that is going, that is RB, and that if we want the perpendicular, it's the force times the perpendicular distance. Okay, so we need to rearrange this to give us that perpendicular force. Then we can use that with the distance. Okay, so in this case, we'd have to, it'll be an RB sine theta. Okay, so that is because we're making it this direction here. Okay, because that is perpendicular to A, okay? It's perpendicular to the slope. So we're going to make it in this direction here because that will be able to give us that perpendicular distance. That's what we want. So that's at an angle of sine alpha, which is why we do RB sine alpha. And that will be times by a 2a. And that is our anti-clockwise moment. And then for our clockwise moment, that's just the weight. So that's the mg. Again, mg we make perpendicular to that slope. Okay, so for this one, that would be this direction here. It'd be perpendicular, so that would be mg cosine theta. So mg cosine theta, and that's just times by a. Okay, and now we can simplify down a bit. So they both have a, we can get rid of the a, and then we're left with a 2rb sine theta is equal to an mg cosine theta. Okay, so now we have got this. And now, actually, let's get an expression for RB while we're at it. So, for RB, that would be an mg cosine theta. And that is minus we're going to divide by that 2 sine theta. So, therefore, we actually know what RB is. We know RB is equal to mg, let's do that half, mg, and then cos theta over sine theta, that is just cot theta. So we've got that RB is equal to a half mg cot theta. And now, we've know what RB is, well, just looking at our diagram, we can work out what F is, because you can see F and RB are the only horizontal forces we have. Therefore, if we resolve horizontally, we just have that F, okay, because we just have this F here, that must equal this RB here. So therefore, F is equal to RB, therefore F is also a half mg cot theta. And now we've done that, well, in our question, we need to, if I scroll back, the question wants us to show that mu is equal to a half cot theta. So right now, we've worked out what our F value is. We now need to work out what our R value is, okay? So, to work out our R value, well, this R value, this is RA, okay? Because if there's friction at A, then it's always mu times the normal reaction at A. So, we need to look at that RA value now. So, how can we get that RA value? Well, if we look, we only have two vertical forces, right? We only have this RA in the upwards direction and this MG in the downwards. So again, it's a nice one in the sense that if we resolve vertically, okay, we just end up with R is equal to an mg. And if we have that, well, now we have that F, which is, if I write F like this, just mg cot theta over 2, we know that that has to be less than or equal to mu, and then R, which is just a mg, okay? So therefore, if we were to work out mu now, well, that would just be a mg cot theta over 2, and then if we divide by mg, that would just be a 2 mg like this. That would be less than or equal to mu, and then, well, the mg's just cancel out, so therefore we are just left with a cot theta, or let's rewrite this as a half cot theta is less than or equal to mu. And then if you just rearrange that, because obviously we want mu on the left side, then the inequality sign will also flip. Therefore, we're left with that mu is greater than or equal to a half cot theta. So again, with that question, just need to work out what your RB is by taking moments. And then once you do that, you can resolve horizontally and vertically to work out your F and your RA, put it into the equation, and you're left with that exact thing where mu is greater than or equal to a half cot theta. So for part B, we have that a horizontal force of magnitude kmg, where k is a constant, is now applied to the beam at A. The force acts in direction that is perpendicular to the wall and towards the wall. Given that tan theta is 5/4 and mu is 1/2, the beam is now in limiting equilibrium. Use the model to find the value of k. Okay, so how can we go about working out this question? Well, if we start with the kmg, well, we're told that it's going to be perpendicular to the wall going towards the wall. So you know that now we have a horizontal force here of kmg newtons. And that was where the friction was going to go. So now we need to figure out what direction is the friction going, because in theory the friction could go either way. The friction could still go to the right, or it could go to the left, okay? But when we think about it, let's just first thing first, actually, before we work that out, let's work out what our values are for cos theta, sine theta. So for those values here, well, we know that tan theta is 5/4, so therefore we would get a 5 here and a 4 here. Now usually we always have nice numbers when we're doing these, but this one is not nice, okay? But actually what we would get is we get a 5 squared plus 16 squared, all square rooted. So that will be a square root of 41. So let's write down these values. So we get a sine theta is equal to a 5 over a root 41. We get a cos theta is equal to a 4 over root 41. But then in the previous question, okay, we actually, for RB and F, we actually had a cot theta, right? So let's write down cot theta as well. So cot theta is equal to a tan theta is 5/4, and cot theta is just 4/5. Now, even though we have these like 5 over root 41, 4 over root 41, we actually most likely may not need to use them, okay? So really, cot theta is the one we really care about. So if we think about cot theta, we'll go back to the previous question, okay? What did we get for RB? Well, for RB, we got that RB was equal to a half mg cot theta. So that would still stay the same. So if we know that RB was equal to a half mg cot theta, okay, well, that would be that a half mg times a 4/5, which then if you work that out, you get a 4/10 mg, which would simplify down to a 2/5 mg. So why is that important, okay? Because it's important because this can now help us figure out what direction our F is going in. So we know that in the question, mu is equal to a half. So what we can do is, if we know that mu is equal to a half, okay, if I write that here, we know that mu is equal to a half, we can actually work out the friction, okay? And that can help us to determine the direction. So it'll be F is equal to a half times by RA. Now, RA is just going to be mg, same as the previous question. Ra is just mg. So we know that F is equal to a half mg, okay? So F is equal to a half mg. So maybe write this in decimal form, it'll be easier to visualize. So we have RB is equal to a 0.4 mg, and we have F is equal to a 0.5 mg. Now, as we can see, just by looking at this, what do we know? Well, as we can see, we know that our F value is bigger than our RB value, okay? We know that our F is actually greater than our RB value. So what does that mean? Well, that means that if F was going in this direction, well, that would be impossible because if we have like a 0.5 mg, well, that friction plus the kmg will be greater than the RB, but they have to balance because they're still in equilibrium. Therefore, the F has to be going in this direction now. So the F is now going to the left, okay? So it's just a little thing like that. Just make sure that your friction, you change the direction as well. Another way you can think of it as well is the fact that the kmg force has now made this beam in limited equilibrium, okay? So before it was just normal equilibrium. Now it's in limited equilibrium, which means that it's on the verge of slipping in that same direction as that force has now made it in that equilibrium. So therefore, friction has to go in that opposite direction as well. So now that we've worked that out, then it's very simple now to work out what K is, because we've got everything we now need to work out. We can just resolve this by forces now. So if we do that, what do we have? Well, if we resolve in the horizontal direction, okay, let me just bring my graph down. We have that kmg, okay, and that would be minus F minus RB. And well, we know that is obviously just going to be a just 0 here. So we have that kmg is equal to an F plus an RB. We've worked out both our F and RB. So we know that our RB, let's write this back as a fraction. So we have a kmg is equal to an F, which we worked out as 0.5 mg. Actually, no, let's keep it as decimals, keep it easy. We have a 0.5 mg. We know that RB is a 0.4 mg, and that means that kmg must equal a 0.9 mg. Well, again, we can just simplify this down. So if we just want to look at what k is, well, mg's cancel out. We are just left with k, and that equals 0.9. Okay, so for this question, we have a small star projected with speed 65 meters per second from point O, vertical cliff. Point O is 70 meters vertically above the point N. Point N is on horizontal ground. So if I add to my diagram here, this is going to be N here. What else do we know? We know that we have an O as well. So O is here. Okay, we know that tan alpha is 5/12. And we need to use, they tell us, this is important, the acceleration due to gravity is modeled as having magnitude 10 meters per second. So usually when we have these questions, we just use 9.8, but in this question, they specifically tell us to use 10 for acceleration, so just remember that. And we need to find the time taken for the stone to travel from O to A. So, okay, let's start with working out the sine alpha and cosine alpha. So for this question, okay, we know that a tan alpha, they tell us, is a 5/12, which means that if we draw this a 5 here, that would be a 12 here. Pythagoras theorem, we'll get a 13 here. So we know that a sine alpha is going to be a 5/13, and a cosine alpha is going to be a 12/13. And just so I don't forget, we know that A is equal to a 10 in this case. Just remember that it's not a 9.8, it's going to be a 10 in this case. We find the time taken for it to go from O to A. So what can we do to work this out? Well, in this question, usually we could just resolve maybe horizontally, but they don't tell us the horizontal distance in this question, so we can't use that. We actually have to use just the vertical. That's all we've been given. So if we use the vertical distance, well, what do we know? Well, think about A. Now, actually, before I do this, we need to remember that in these questions, okay, but especially within the vertical direction with projectile motion, when we are doing the vertical, we need to really specify the direction because that will change some of our values. Okay, for example, if we consider upwards as a positive direction, then our S would be a minus 70. Now, why is that? Well, because if we start at this O value here, well then if we're going to A is over here. So if we're going here, then really, let's say we go up, let's say we go 80, 90, 100, 110, 120, and then we're going back down, it's going to be 110, 10, 90, 80, 70, 60, 50, 40, 30, 20, 10, 0, right? Now, the whole idea is that if we start at O, if upward is our positive direction, that means that we're actually going to go 70 meters downwards. And if up is our positive, then downwards has to be our negative. So therefore, it's going to be a negative 70, okay? Because we're already starting 70 meters above. So negative 70. Just remember to get your values the right way around. That's a minus 70, okay? Our U value. Well, our U value, we know it's 65. So it's going to be a 65. But we're doing vertical, so that'll be a sine alpha. We know sine alpha is at 5 over 13. So for now, I'll write it as 65 sine alpha, but then I will plug in that 5 over 13 at some point. We don't know what a V is. We don't need to know what a V is. Our A. Now, again, A, when we are traveling downwards, A is positive. When we're traveling upwards, A is negative. In this case, A is 10, so it will be a minus 10. And then T, that is what we want to work out, so we can just leave that as T. And we have S, U, A, and T, which means that we will use the SUVAT equation of S is equal to a UT plus a half AT squared. So we get a minus 70 is equal to a 65 times a 5 over 13, okay? And that is also times by the T. That is plus a half times a minus 10. So minus 10, that's a minus 5, okay? But then we also have that t squared. So that would just be a minus 5 t squared, okay? And then that's a minus 70. Now, if we work out 65 times 5 over 13, you get a nice number. You get 25, okay? So we get 25t minus a 5t squared. And now, as you can see, this is just going to be a quadratic equation. So therefore, if we rearrange this, we get a 5t squared minus a 25t minus a 70 that is equal to 0. Let's just divide everything by 5. So we get a t squared minus 5t minus 14. And that is equal to 0. And then two numbers with sum to make a minus 5, multiply to make a minus 14. That would be a minus 7 is one of them. So that's a t minus 7. And then a plus 2. And that's equal to 0. Therefore, we get t is equal to 7 and t is equal to minus 2. So which one do we use? Well, in the question, I assume they do say it somewhere. They don't, but it doesn't actually matter because obviously we're dealing with time. Time is always going to be a positive value, always going to be greater than or equal to 0. Therefore, our t value would just be t is equal to 7. Sometimes they do tell you like t is equal to 0. If they don't, does really make a difference. We should also know that t is always going to be a positive value. So in this case, we get t is equal to 7. So we know that our time is equal to 7, and that is the question, I believe. We've worked out how long it takes to travel from O to A. It takes 7 seconds. So for part B, we need to find the speed of the stone at the instant just before it hits the ground at A. So what they really want us to do is, because it says the speed, okay, that means that what we need to do is work out the vertical component of the speed, okay, or the velocity, the horizontal component of the velocity, and then use Pythagoras' theorem, and then that will give us the speed, okay? So first thing first, let's work out the vertical velocity. Okay, so what are SUVAT values then? Well, what do we know? Well, we know that S, okay, and now remember that we are considering that if we're doing the vertical, the upwards direction, that is going to be our positive direction, okay? So therefore, S is a minus 70. Okay, U, well, we know that U would be a 65 sine alpha, and we worked out what sine alpha was in the previous question. So we actually know what this is. This one would be 65 times by that 5 over 13, okay? And that gives us 25, as we worked out in the previous question. And then our V value, well, that is what we want to work out, okay? Because we want to work out the velocity just before it hits the ground. So we know that our V value, okay, that is what we're working out. So we can leave that as V. And we know in this question, our acceleration is 10. But again, because we're considering the upwards as positive, then our A would be a minus 10. And we could also use, can we use T as well? We can actually use T as well, because we do know that T is equal to 7, as we worked out in the last question. But it's best not to use that time which we worked out, just in case that question, in case we worked out the time wrong, then our answer would be wrong for this, right? So if you can, try to avoid using your previous answer if you don't need to, okay? So we can use these values here, S, U, V, and A. And the SUVAT equation, when we have S, U, V, and A, that is a V squared is equal to a U squared plus a 2AS, okay? But again, obviously, if you're very confident in your answer for time, you can just also use your time as well. But we're going to use this. So if we work this out, well, we know that's going to be V squared, okay? So it's a V squared is equal to a U squared, so that's a 25 squared, plus a 2 times a minus 10 times a minus 70. So let me write that all in. So a 2 times a minus 10 times a minus 70, which gives me V squared is equal to a 25 squared. So if you do that in your calculator, that will be a 625. Let me zoom in. 625. And then you do a 2 times a, let's see, the 10 times minus 70 first. So that would be a positive 700. And then you times that 2, that will be a 1,400. Therefore, we get V squared is equal to a 2,025. And then if you work out the square root of that, that is exactly going to be 45. Okay, so what does that mean? Well, we know then that the vertical component, okay, we know that the vertical velocity, okay, we know the vertical velocity is equal to a 45 meters per second. So that's the vertical part done. Now we need to work out the horizontal velocity. So how can we work out the horizontal velocity? So if we look at the horizontal component, okay, well, we actually don't really need to use an equation as such. But again, the horizontal speed, well, it would just be that 65, okay, and then it'll be just cos alpha. Okay, that would be the horizontal velocity. So in this case, it'll be 65 cos alpha. And we know from our previous question what cos alpha is. We know cos alpha is 12 over 13. So therefore, it's 65 times a 12 over 13. And if you work that out, what do you get? 65 times 12 over 13 gives us exactly 60, okay? So we know that we know that the horizontal velocity, okay, is 60. Now, what does that look like? Well, effectively, now if we look at the speed, if I draw a little diagram here, okay, then we're going to have the vertical component will be going downwards, okay, which does make sense because if you think about how this graph is kind of looking, okay, it's like looking like this. So we're going to have the vertical there, and then we're going to have the horizontal looking like that. So if I just draw that, it will look something like this. Like this, okay, and then there's a right angle here, and then it will go like this, 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 and we know that this is going to be not 70, this is a 45, that's the vertical component, and we know that this is a 60, and we want to work out, the actual speed. So we just use Pythagoras' theorem, and using Pythagoras' theorem, that will be a 45 squared plus 60 squared, all square rooted. And if you work that out on your calculators, what do you get? Well, oh, you get a 75 meters per second. For part C, one limitation of the model is that it ignores air resistance. State one other limitation of the model that could affect the reliability of your answers. So these kind of questions, they come up a lot. Easy one markers. There's so many things you can talk about. I'm going to use the same one I always use, and that is the shape and dimension of the stone could affect its motion. Okay, you can say something like that. Easy one marker. They come up all the time. Yeah, not much else to it. So for question 5, okay, we have at time t seconds, the particle p at velocity v meters per second, where v is equal to 3t to the power of a half I minus 2tj, where t is greater than 0, and we need to find the acceleration of p at time t seconds, where t is greater than 0. So for this question, it's like a variable acceleration question with vectors. So to work out the acceleration, all we need to do is just differentiate, okay? Because we're given the velocity, we know that if we differentiate the velocity, that'll give us acceleration, and if we integrate the velocity, we will get the displacement. So for this question, let's just we need to work out the acceleration, so you just need to differentiate. So let's do that down here. So I've written what v is, and I just need to differentiate this. So a is equal to a dv over dt, and that will be if we differentiate that, we get a 3 times a half, so 3 over 2 t, and that is to the power of a minus half I, and then that's just a minus 2j, and that is our answer. Okay, that's our answer for part A. And for part B, we need to find the value of t at the instant when p is moving in the direction of I minus j. So if it's moving in the direction, that means that the velocity has to equal some type of scalar of I minus j. So if I do that down here, what does that mean? That means that for the velocity, so the 3t to the power of a half I minus 2tj, it must equal some type of scalar, let's call this lambda, of I minus j, okay? And now we can just equate the i's together, the j's together, and we can work out what the value of t is. So let's equate the i's first. That would be a 3t to the power of a half I, and that would equal lambda I, okay? And then we also, let's do the j's now. For the j's, it would be a minus 2t, okay, and that would equal a lambda times a minus j, a minus lambda j, okay? So going back to the i's, if we get rid of the i's now, that would just be a 3t to the minus half is equal to lambda, and for the j's, we would just get, we can actually eliminate the negatives as well. That would just be a 2t. Oh, and there should be a j here, sorry. That'll just be a 2t is equal to a lambda, okay? So now that we've got 3t to the power of a half is equal to lambda, and we've also got 2t is equal to lambda, well, that's just simultaneous equations, okay? Because both those lambdas have to be the same value. So therefore, we can equate them together, which means that we would have 3t to the power of a half is equal to a 2t. And now we can just work out what t is. So let's bring all the t's to one side. Okay, so we get a minus 2t over here is equal to 0. Take out a factor of t, so we get a t is equal to a 3t. Now what would that be? That would be a minus a half, okay? Because if you do that t times a 3t to the power of a negative half, you would get the 3t to the power of a half. So we get a negative half inside the brackets, and then we just get a minus 2 here is equal to 0. Therefore, t can equal 0, yes, but in the question, remember that it says t has to be greater than 0. Therefore, we don't want to take the solution where t is equal to 0. Therefore, we need to work out this solution here where we have 3t to the power of a negative half minus 2 is equal to 0. So 3t to the negative half is equal to 2. T to the negative half is equal to 2 over 3. And then if we do over here, therefore, if we do t to the negative half, if we raise everything to the negative 2, okay, that would be 2 over 3 to the negative 2. Therefore, that leaves me with a t is equal 2. If we flip that first, we get 3 over 2 squared, which therefore leaves me with t being 9 over 4. So for part C, we have a time t seconds where t is greater than 0. The position vector of p relative to a fixed origin O is r meters. So in this case, usually when we have displacement and we call it s, in this case we'll call it r. We also know that when t is equal to 1, r is equal to minus j. So that will come in handy when we have our constant. We need to find an expression for r in terms of t. So a fairly nice free marker there. What we need to do is, well, we know that in this case, we know that r is the integral of v with respect to t, okay? And then we need to work out what r is, okay? So to do that, well, we know that r is equal to integral of 3t to the power of a half I minus 2tj. So we need to integrate this now with respect to t. So if we do that, we get r is equal to a 3t, and if you, that would be 3 over 2, because we add 1 to it, and then we just divide by that. So divide by 3 over 2 I. This one would be a 2t squared over 2, and that would be a j. And then obviously don't forget the plus c, as I nearly did. So we work out, so if we simplify this down now, we get a 3 divided by 3 over 2. That's the same as saying 3 times by 2 over 3. So that's a 2t to the power of 3 over 2i minus t squared j plus c. And then we know from the question that it says that when t is equal to 1, r is equal to a minus j. Therefore, if we substitute those values in, we get a minus j is equal to a 2 times, well, 1, effectively, so that's just a 2i, and then minus a t squared, that's minus a 1 squared, so that's still going to be a minus there, j, plus c. Obviously, our j's would just cancel out, and then if we bring that 2i to the other side, we get a c is equal to a minus 2i. Therefore, our r value would just be a r is equal to a 2t to the 3 over 2i minus a t squared j minus a 2i, and then we can just group our i's together. So we get r is equal to a 2t to the power of 3 over 2 minus 2. Then all of that would be I minus a t squared j. So for part D now, the last question, we need to find the exact distance of P from O at the instant when P is moving with speed 10 meters per second. So again, with this question, it says the word speed, okay? So whenever you see speed, think about Pythagoras' theorem. That's all you got to think about, Pythagoras' theorem, and you're good, okay? So what does that mean? Well, that means that if it's our speed, okay, well, what do we know? Well, we know that in this case, if it wants our speed, well, in this case, we know that our v value, I've written this so many times, but I'm going to keep writing it. So we know that 3t to the power of half I minus 2tj. Okay, we know that is this. We know that is the velocity, right? Okay, but they tell us that the speed is 10. So what does that mean? Well, that means this. It means that 10 is equal to a 3t to the power. Remember, I and j, they're just the vertical and horizontal components. 3t to the power of a half squared plus the minus 2t squared, all square rooted, okay? That is what it means. What happened there? That is not what my square root should look like. All square rooted. That is what it's saying, because it's the speed, okay? So if we know I is a horizontal component, we know that our j is the vertical component. Well, then if we want the speed, we just need to do Pythagoras' theorem on that velocity, right? On that v. And that would give us the speed of 10. So if we know that, well, now we can actually just work out what a t value is. And once we know what a t value is, well, then we can just plug that in to the equation of r we just worked out in the previous question, which is this. We can just plug it into this. And then once we know what the value of r is, well, then it asks for the distance, and the distance, again, that's a scalar term, so then we just use Pythagoras' theorem again to work that out. So, again, first things first, let's look at the time. So look at the time, let's work this out. So that's square root. Let's bring the square root to the other side. So if we bring the square root to the side, okay, that means that we're going to square everything. And if you square everything, then we're going to get a 10 squared. So we're going to get 100 equal to a 3t to the half, still squared, and then still have that minus 2t squared. So if 100 is equal to, well, then how do we work this out? Well, if we do this first, we do a 3 squared first. So a 3 squared is a 9. And then a t to the power of a half, you times that by the 2, that would just simply lift with a 9t. And then for this one here, a minus 2t squared, well, that would just be a positive 4t squared, okay? Now, if we bring everything to the same side, we would get a 4t squared plus 9t minus 100, and that would equal 0. And now at this stage, it's now just a nice quadratic equation, okay? So again, you could do this by hand, but again, in this question, it doesn't say anywhere where you can't use a calculator. It's not one of those questions where it wants you to show you're working. So at this point, just use your calculator to work this quadratic equation out. And if you use your calculator, you'll get two values. You will get t as 4, and you'll get t as a minus 25 over 4. Okay, but remember, obviously, we're dealing with time, and also in the question, they even tell us that t has to be greater than 0. So we know that with our two values here, only one of them can be right, and that is when t is equal to 4. So what does that mean? That means that when the speed is 10 meters per second, okay, we know that that will happen at 4 seconds. So if we know that's going to happen at 4 seconds, and we want to find the distance of p, okay, well, now we know what the time is. So now we can put that in to this equation here. We can put it into our R equation because this was all about the displacement, okay? So we can just put that 4 into this, and we can work it out. So if we put the 4 in, okay, what would that be? Well, that would be an R is equal to a 2 times 4 to the power of 3 over 2 minus 2 I minus a 4 squared j. So just be careful with your minuses. Remember, it's just that 4. It's like a minus times a 4 squared, so don't group it all together. Otherwise, you get the wrong answer. So now let's work this out. So we get a, so we have to do indices first. So we would get a, we do 4 to the power of 3 over 2 first. Well, if we square root that, we'd get a 2, and then cube root, we get 8. So we get a 2 times 8, which is 16. And then minus the 2, we get a 14i. And then for that one, the j, we get a minus 16j. So we've worked out that r is 49 minus 16j, but in the question it asks for the distance, so we have to do Pythagoras' theorem. Therefore, if we do Pythagoras' theorem, we do a 14 squared plus 16 squared. Okay, and if you work that value out on your calculators, you will get the grand total of, if I do the exact value first, you'll get 2 times the square root of 113 meters, and you can leave your answer like that. Okay, that is the exact value, 2 root 113. And that is this paper done. I think this paper was definitely hard. I definitely think the more recent ones are a bit easier. The more recent papers, they give you 6 questions, and it's a bit more, and as a result, there's less questions on each, so I feel like it's a bit easier maybe. These older ones seem to have 5 questions a lot, so they're definitely a bit more bulky, but still a decent paper. But yeah, I hope you enjoyed this. Next video, I will try and do 2020. Hopefully, I'll get it out just in time before the mechanics exams this year. But yeah, I hope you enjoyed this video, and I will see you soon.